And we'll proceed on to the next presenter, Michael Starch of NASA Jet Propulsion Laboratory. He'll be talking to us about leveraging open source development to enhance the F-Prime flight software framework. Michael.
Okay, hello everyone. Thank you for that introduction. My name is Michael Starch. I'm a flight software engineer at the Jet Propulsion Laboratory in Southern California. Next slide, please. So a little bit about this talk. I'll give you a brief introduction to who I am and a brief introduction to what is the F-Prime flight software framework. And then we'll get into the meat of the talk, which is how F-Prime has approached open source and how that has evolved over time, some of the benefits that we have of going open source, and probably the most pertinent to the attendees is the lessons learned that we've picked up trying to do open source. Next slide, please. So this is me. I'm sure you can see my camera feed as well. I'm a flight software engineer at the Jet Propulsion Laboratory, and I'm also the technical product lead of the F-Prime framework. That essentially means I manage the open source community and try to take this framework, which is applied to a number of projects, and move forward the core pieces that we share with the world. I've also been doing open source on various projects for nearly a decade. Next slide, please. So we'll talk a little bit about what the F-Prime embedded systems framework is. Next slide. So F-Prime is overloaded like many technical terms. We are a framework that is the standard components, the development tools, and the references that you all could use on your projects, that our customers use on their projects, etc. We also have what is known as F-Prime community, which is the extra stuff that you could use as part of a project. So whereas the F-Prime framework is kept up to flight software standards and is designed to be, flight and launch ready, the F-Prime community stuff may not come with the same guarantees, but nonetheless, it is essential for projects to see various examples, prototype code, all of that stuff that is useful to people and is useful to projects, but doesn't necessarily come with the backing of the F-Prime core team. And then of course, F-Prime also refers to product adaptations. So where you see F-Prime used as the flight software framework for CubeSats, instruments, deployables, all these things are generally referred to as F-Prime. So moving into the next slide, we can talk a little bit about what the core framework is, because that's what this talk is discussing. F-Prime, what I call the core framework, but what really is the F-Prime framework, is a set of documentation, standard components, code, tools, and reference examples that projects can use to expedite the creation of embedded systems applications. At JPL, we call them flight software applications because, again, we're designed to go onto satellites, CubeSats, the like, and be launched into orbit. But our framework isn't limited to just that. You could use us to build any number of embedded systems applications. So the core framework, as stated on this slide, comes with standard components. These are the things we like to call the ground interface or events, telemetry, and that sort of thing, along with other pieces that help do command and data handling for a spacecraft. We also ship with documentation that tries to explain what the framework is, the best practices, and a lot of information that you'll see we generated from the open source community as we get into open source later in this talk. In addition, F-Prime comes with auto-coding suite to help generate F-Prime applications more quickly and effectively, and it comes with a set of testing tools, a GDS, an integration and test framework, such that you can test these applications quickly. And then, of course, we ship with a few reference examples, and the nominal example that I like to point to is the Raspberry Pi example, because that shows how to do F-Prime in an embedded context on a processor that is about as cheap as you can get an embedded computing system. So that's a little introduction into the F-Prime framework, and now we will start talking about F-Prime and our experience with open source. Next slide, please. And next slide again. So in order to understand F prime and open source, we have to get into some of the history pertaining to F prime and how we were developed. F prime was created in a series of research projects at JPL right around 2013. And it stayed in internal development until about 2017, where we did the pretty standard thing for projects that want to do open source but haven't quite figured it all out yet, which is dump code on GitHub and say it's open source, which is pretty normal in the open source community. I see that a lot with projects. Things get put onto GitHub and or some other repository for code. They check the box of we've done open source, and then they move away from it. And then several years after 2017, I joined the project. I looked at how we were doing open source, and I've been trying to push the F prime project to move to a more open development model. So between 2017 and about October of last year, I would say we were doing blended source development. So some internal development and then very infrequent and hopefully increasing in frequency deliveries to GitHub. And we'll talk a little bit about our open development model as of October a little later in the project. Next slide, please. So the way we handle actual development in open source is to use what is essentially a slightly modified Git flow model. So Git flow is you have a master branch, a development branch, and then a series of feature branches where development actually takes place. The master branch is what every customer uses, or at least they should be. It comes tagged, versioned, and easily traceable. The development branch is where you merge all of the work together, and that development branch feeds into the master line to create these version deployments, and then every feature you do in a feature branch. So this keeps development fairly streamlined. The develop branch is fairly stable, and the master branch is designed to be very stable and traceable. And then the only difference from the standard Git flow model is that line you see across the center of this diagram, which is we drive these feature branches out into developer forks on GitHub. Rather than happening on the NASA core repo, we say, go ahead and fork F prime and make a pull request back. And this mirrors just about all of the development that I see in big projects on GitHub, where you fork the project, you make your change, you do a pull request, and the project itself maintains a devel line and a master line. So that's kind of how the code comes together on GitHub using the Git flow model. Next slide. And the last key piece for F prime's development in an open development environment is tooling. We use as much tooling that we can pull in from the environment as possible. So we take advantage of the looks good to me service that you see up there in the upper left. That does our static code analysis. Looks good to me is a website from the SEML folks that does SEML static code analysis on various languages, and they give you free access if you're an open and free product like F prime is. Also, we take advantage of Doxygen and Sphinx. These two tools allow us to generate our documentation from code comments, and so that makes our development and documentation much easier because we can pull in from nice, well-refined code and generate pretty standard templates for where our documentation lives, how it's organized, so that users who have seen this kind of documentation can walk through there and know kind of what to expect and find for themselves the pieces of the documentation they need to understand. And then lastly, we are using GitHub to orchestrate all of this. So you can see at the bottom, GitHub is running our continuous integration. That means we're running unit tests, integration tests, and several other checks on every single pull request that comes in. And we also dispatch to looks good to me directly so that we do static code analysis using SEML on every pull request. And so all of these pieces are crucial to make it easy to manage an open source project with our infrastructure team, which is not as large as most flight software teams. That is because we are the core framework, but we're not hired by any specific project, and therefore specific projects tend to have larger budgets and more flight software engineers operating for them. And so in order to compensate for a smaller team, we use as much automated tooling as possible. So now we'll talk a little bit about how this approach to open source has benefited F prime. So next slide, please. And again, next slide, thank you. So the first and major benefit of moving to open source is oversight. Like I just stated, the F prime team is fairly small. It constitutes 3 engineers and none of them are hired full-time on F prime. But we have an open source community of hobbyists, and I say hobbyists, but I mean people outside of NASA JPL who are working on F prime and contributing to the community, not necessarily as a paid occupation, but as people who just use or want to improve the product. And so the result for F prime is we've gotten a lot of documentation edits because they come in, they read our documentation and they say, hey, this doesn't make sense. Or they come in and use F prime and they find errors in F prime, typically in our test GDS, where they're using the F prime framework and the GDS in a way that we had not seen before on internal projects. And so the result is they create error reports, bug reports, feature requests, all that improve the framework and make it more usable, more user-friendly, and drop lessen the amount of investment you have to take to learn the framework itself. And then finally, this extended oversight results in better design and code reviews because people come in and they look at the code reviews that we're doing out in the public and they say, hey, you need to improve this. Hey, you need to improve that. Hey, this doesn't look like flight software, or this doesn't look like it would fit with my project. And that gives us better insight into the code that we're pulling into the core framework. And so this category of extended oversight means my development team, my infrastructure team, although the people that I can actually go to talk to internally to JPL is relatively small, the people in the community who are all providing these essential parts of flight software development is much, much larger. And in fact is not limited to anything but the entire development community on Earth that has access to GitHub, because again, it's open to everybody on the planet. Next slide, please. So coming out of that community isn't just a greater development or a greater test group, but we start to build a community of expertise. And so what that means is F prime had its uses internal to JPL. We use it on a few CubeSats, but this community is building new use cases, best practices, patterns, everything you can think of on what F prime can do and how to do certain applications with F prime very well. So you can see there laid across the bottom of our slide, this community of expertise is producing best practices, answers to questions, and recommended patterns. And this is essential because I, as a member of JPL, I don't have the budget to try everything that F prime could conceivably do. So internal to JPL, most of our applications are refined to CubeSat projects, deployables, the sort of thing that I mentioned at the beginning of the slide. But in the greater F prime world, I know people are using this for embedded system applications, testbed applications, their own micro CubeSats, that sort of thing. And from this, they generate this expertise community that fills in the gaps for new users. So the best example I can show of this is there's a university that is using F prime on CubeSats that are way smaller than anything I've seen. In fact, they're flying a chip that's very similar to the Arduino processor. So it has something like 8K of RAM and it's 8-bit processor, I believe. So it's much smaller than anything that I've looked at personally. And through working with this community of expertise, they've developed best practices on how to deploy F prime into an embedded system context that is a very miniaturized embedded systems, and they've answered questions on how other projects that want to use other small processors might approach that. And then in addition, they've created recommended patterns on how to run F prime without the benefit of an operating system, that is bare metal. Next slide, please. The final benefit to F prime going into open source is we've started to build an ecosystem surrounding F prime. So that means we're getting better tooling. This isn't necessarily tooling that we're providing yet with the core framework, but there are lots of teams out there in the F prime community building tools that do extra things. So for example, one of the most recent tools that's come into the spotlight is a linting application. It looks at your F prime deployment, your F prime model, and it says, I can check this model for known errors in F prime and produce a report of where you may have made mistakes at the design level that typically doesn't get revealed until much deeper in the process. So where we do linting on code, we can now do linting on specific F prime applications. And that is a tool being developed outside of the core framework as part of the larger community. Also, this community is creating libraries that are useful for the general public that can help with F prime applications. So these are libraries that add in certain components, or for example, that bare metal setup that I talked about. That's out there. And parts of the library that support that bare metal framework are available not necessarily in the framework itself, but as part of this greater community. And then we've already discussed these new use cases where F prime is being configured and modified for smaller and smaller environments that are outside its original its original bread and butter, if you will, but nonetheless very important to our community. And so overall, we have this thriving ecosystem that represents F prime as a larger entity. Next slide, please. So the last key takeaway that we have is, what lessons did we learn going to open source? So the first lesson learned, the big one, is embrace openness. If you're thinking about going open source with your product, go wholesale into open source. For far too many years, we ran F prime as this kind of split model that I talked about, where some of the development was done internal, some of the development was done external, but mostly it resulted in 6 months of nothing and then a giant delta, and then 6 months of nothing and then a giant delta. Then, as of October, we've moved to this model. This is mostly due to my team shrinking a little bit. And so I couldn't any longer really afford this split model. So we just said, all right, we're going wholesale, and we dragged everything to GitHub. So our project management is done via pull requests and issues on GitHub. We do our software releases and our documentation on GitHub. As you saw earlier, we're doing continuous integration and contribution and pulling in contributions to F prime, all on GitHub. And then we have a Google mailing list that isn't on GitHub, but it's still open, where we handle most of our questions. And so in this way, all of our model is open. The entire world can now be involved in the whole process. And that benefit of extended oversight is done across the project. We no longer, or at least we're trying to no longer, have anything hidden behind the scenes, but make sure that everybody who uses F prime can see it. Next slide, please. So the other lesson learned, and this is a lesson learned that I've seen time and time again on every open source project I've been involved in, is you've got to keep the product line, that is your open source product, separate from your specific use cases, the real projects, if you will. For example, your CubeSats. And the reason for this is those CubeSats have budgets, schedules, and shortcuts that they make that are acceptable and 100% the correct engineering choice for their project, but they don't necessarily have the time and the budget to engineer at a generic level. So if you allow your product to get coupled to a specific project, say one CubeSat, when you're done with that particular CubeSat or that particular mission, you have a very high risk of having your product line end there. It becomes so tailored to that specific product that it's no longer usable by anyone else, and it dies. And so F prime, we hit the ground running understanding this due to a very long history that I've had of working on projects that struggle with this. And we set a boundary between between the F prime framework and our specific projects early on. And we've been able to maintain that separation. And it means that we have customers coming in from a number of universities, industry partners, and other projects at JPL ourselves that can use this product without worrying that it's only good for CubeSat applications, or it's only good for deployable applications, etc. Next slide, please. And then my final lesson learned is use tooling. If you're going to go open source, use open tooling. Most of this tooling that these companies provide out there in the open source world are available to free if your product is free and open source. And the reason for that is they want to get their product out there, and they want to get integrated with your free and open source version so that people who adopt it might consider, using this on their projects themselves. But as an open source contributor and a manager of this free and open source product called F prime, all of these free tools means that I can integrate with industry standards and take advantage of all of this stuff to make my product better without needing to do these steps manually. So looks good to me. It does static code analysis. It runs SEML on my code, every pull request, so that anything that's going to be contributed to F prime, I can see where it might decrease our code quality. Docker that you see in the middle, we use that to run our continuous integration tests by packing our embedded environment in a container. And in this way, we are able to repeat our tests exactly every time so that we know there aren't any false positives in our testing, but failures are actually things that need to be corrected before this pull request merged in. I've already talked about documentation, but creating standard documentation is awesome for F prime. And then down at the bottom, we see GitHub is used to integrate all of these tools based on pull requests. So all I have to do is manage individual items as people submit them, and all these tools kick off automatically. And then a new tool that we're starting to integrate in is the cookie cutter suite, which is starting to bring down development time because we're taking advantage of standard tools. Next slide. So now I'm available for a few minutes, I believe, for questions.
All right, thanks a lot, Michael. We do have a few questions. First question from Chris Heestand. How do you get funding for a product line if you aren't tied to the project?
How do I get funding for a product line if I'm not tied to a product or a project specific? So that's a great question. And that's a question that we deal with on just about every open project that we have. And so typically these projects start out as very project specific. And then through a little bit of extra work from engineers, they pull off the piece that is useful. And then typically the pattern is that I've seen is that you can then write specific proposal calls to more like technology development proposals and propose a framework, and you get a little funding of that to refine it into a product line. And then you also have to do proposal calls and things to various agencies that might give you a little bit of a maintenance budget, or hope that you've grown the community large enough that you can sustain it long term. Lots of open source projects out there in the real world go through a similar path, but at some point they spin off a company that is dedicated to selling a service around your open source product, and they sell that service, support to that service, and then they maintain the software itself as open source. We haven't gone that line because F prime came out of NASA, and so I don't really think it's viable to spin it off as a separate company. And so we tend to go the proposal call route, where we're proposing to various public proposals to maintain technology. But that's a balance point that every project has to make, and there are trade-offs between the different models there.
Okay, excellent. Let's take one more question, and then we'll split off the slack. So next question from Vito Fortunato. How does F prime relate to CFS? Are they exclusive, or can they be combined in some way?
So this is the question we always prepare for, because there's always a question of how does F prime and CFS, how do they relate? at the highest level, we're solving similar problems. CFS is designed to create embedded flight applications, and so is F prime. At a technical level, F prime uses a point-to-point communication network rather than a communication bus. And we offset the extra overhead and the extra work of developing point-to-point communication by auto coding from your project model the actual communication layer. So it's a component-based framework. You drop components down, you link them up in the model, and then all of that point-to-point communication is generated, so you don't have to write the code. And the basic rationale for that is that typically our flight software applications, have a static topology once you launch. And so we didn't think we needed the power of a communication bus. And also F prime is written in C++. And if I remember properly, core flight software is written in C. Now, the question is, you can see that you could build your application in CFS or F prime, but there is this idea of combining the two. And so we, as F prime, have this component-based framework. So it would be fairly simple to build components that translate the F prime point-to-point architecture into the message bus architecture for CFS, and then you could integrate the applications. So if you needed to, say, deploy some F prime components quickly into a CFS for something like a research purposes, where you don't necessarily have the budget to rewrite everything, but you want to get them in and test them, you could link up with just a few components and tie the two together. And then the other chain works as well. You could tie CFS underneath an F prime application if you needed to do that. So typically projects would do a trade study. These are the big flight projects, and look into which one would work best. But for smaller projects or research projects, there is an understanding that you could link the two to get a quick prototype or an understanding as you approach larger projects that then might want to pay for a rewrite, but don't want to pay for a rewrite if such components don't have any like proof of concept available.
Excellent. And I do believe that you prepared for that question. Thank you very much, Michael. Excellent presentation. I will copy the remaining questions over to Slack.
Okay.